Hello, my name is Keegan, and today I am going to be talking about spring mass systems. Yay! Alright, so here's some things you'll need to know. First of all, you've got to know all these. These are very important. These things over here. Those are very important. You will need to know those. Ignore this squiggly line, it's useless. What is a spring mass system? It's this thing. It's a wall, and a spring, and a mass. And basically, all these questions we'll be asking you is, hey, what is the spring constant? Hey, what is the displacement? Or hey, what is the mass or period? And so I'll show you how to solve for all of those here in a minute. But first, I'll tell you that to solve for the period, you need to know 2 pi m. Yeah, I'll just cut this part out. Alright, okay, I cut a piece out. I don't know if this is gonna work out, but I don't know, I guess I'll try anyway. You have your T of S, which is your period, your F of S, which is your force. So this is like the force being applied. This right here is the force being applied to the mass. It'll go, Lear ways or this ways or that ways or something, and you have to know, hey, what is the constant, or hey, what is this thing, or what's that thing, or another thing, or something. I don't know. Let's say you have a constant, a K. Think of it like a stretch or compress or. Here you have a constant, K. It's 5 Newton meters. Think of that as spring stiffness. Is it stiff, or is it maybe like a slinky? It's not so stiff. You have a displacement, X. So the difference between where this bobber thing goes when I push on it and where its equilibrium point is. If you want to know what the equilibrium point is, I don't know, just Google that. I don't care. So let's say you have a spring, a mass. Okay, so the mass, here's the mass, our object. That is this thing right here. The mass of that is 200 grams, 0.2 kilograms. Always use I wrote always use kilograms right here. Obviously, that's the most. Kilograms are the unit you're gonna want to be using for mass. And oh yeah, these are the units. You'll need to know those. They're also very useful. You'll need to use it. Trust me. Okay, shut up. You'll need to use those. Find the spring force and spring period. So we have all these things up here. We've got this, and this. We have those written right here. And we use those, and we plug them into our equations. And we find the answers. If we get a negative answer for F of S, we know it is either downward if the system is vertical, but if it's horizontal, like this one, then it is to the left. That's where that's where the spring is wanting the mass to be moving. If that makes any sense. This video is. Yeah, I wrote that. Always round to the 10th if it does not tell you to round to the 100th place or whatever place. Real life applications, I guess you have to know these. They were in the requirements for the project, so I'll be talking about them. Pogo sticks, trampolines, and car suspensions are all some examples of spring systems. That works because they're springs. This one's kind of self-explanatory. Trampolines, that's just the same thing, but some geometry is involved, and the car suspensions, nobody cares. Let's go to example uno. Bobo Clown weighs 158 pounds, which is 703 newtons. Bobo Clown gets on a pogo stick, and he causes the spring mechanism to compress roughly 0.25 meters. Find the spring constant on the pogo stick, assuming there is no friction and the pogo stick itself has no mass. Compress. That was a horrible... God, I can't underline any little shit. It compresses, so it's a negative. And we have our things right here. These are the given, these are what are in the problem. So we already have these. Now we have to say, oh, what does it want us to solve for? Oh, it wants us to solve for the spring constant. We know that is K. So if you want to, you can go and solve this by yourself. I'll be back in a second. I'll just cut out the part that's like of me solving it. But I'll explain the whole worked out thing here in a second. Alright, I'm back. The torture has not ended. This was a very hard problem. The answer is 175.75 Newton meters. There we go. If you didn't get this, sorry, but you're wrong.